Hey, what's going on, guys? How all you are doing? Welcome to a new video tutorial from IP News. Today we're gonna talk about a really nice topic. I've been excited about talking and putting a new video tutorial on the channel actually for a really long time, which is a blockchain. So in this video tutorial, we're gonna create a blockchain using Node.js. So we're just gonna start in here, give you what is a blockchain and give you a quick overview of what is a blockchain and why it's very important. And some of you might have heard about blockchain because it has been growing so fastly in the last couple of years, and you obviously know about cryptocurrencies and stuff like that. So cryptocurrencies actually are based into the blockchain. So let's just dive right into it and start talking about blockchain. So first things first, what we need to know about is what is a blockchain. So blockchain is originally a fastly growing endless chain of blocks where each block represents an immutable data, which makes it super powerful in terms of dealing with sensitive data. So each block in the chain is immutable. So once you create the block, you can't change the block. The data into the block can't actually change whatsoever. So it's widely used for cryptocurrencies like Bitcoin and lithium. Most of you knows about Bitcoin, and Bitcoin is actually based on the blockchain technology. It uses a cryptography algorithm to prevent data forming by block hashing, where each block has its own hash. So once you create the block, you're gonna hash the content of the block, so that gonna be a unique hash using something like cryptography algorithms to create the hash, then save that hash into the chain. So that gonna prevent the chain or prevent each block on the chain from changing. So whenever a block from the chain changes, the chain is gonna be corrupted, and you can't actually access any other blocks from the actual chain, and that means that the chain is corrupted. So the system would know that this is not a valid chain, and it would know that there's something bad with this chain, or some kind of mismatched data, or some hacker who try to access some kind of things or change some data. So this is how actually tries to prevent things up from modification, which allows the chain to be safe from an unauthorized modification. So this is actually how a chain would look like. In this example, we are going to use Node.js, and we will create a simple blockchain for a very basic cryptocurrency. Let's try to call it, just for fun, deep currency. So this currency, don't take it in a very big deal, because it's going to be a very basic thing, very simple. So yeah, this is all we're going to cover. So here's how actually a blocks of chain would look like. So there's a bunch of blocks, and as you can see, there's some kind of a lock under this block, which means they are unmodifiable or immutable things. Once you created it, once you attached it to this chain, you can't change it whatsoever. So let's start creating our blockchain using Node.js. So actually, before starting, I want to just mention that you can go ahead and learn about ESX classes on JavaScript, because I've introduced the last video tutorial about ESX JavaScript class syntax, and I've just given a quick overview of how classes actually work, how to initiate classes, basic things to start working with classes, to work actually with classes on JavaScript right off the box. So make sure to go ahead and watch the video, or you can read through the written tutorial. Everything is just well self-explanatory. Make sure to go ahead and use that, because in this video tutorial, or in this particular tutorial, we're going to use the classes in order to create the blockchain class. So actually, let's start by creating the blockchain. So the blockchain is going to be a class which holds the chain that we're going to use. So you remember that we're going to create that in a very basic thing. So let's just go ahead and create the class. The class is going to call it a blockchain, and create a class. Also make sure, as I've said, to watch the video in order to understand all of that if you're not already familiar with classes. So classes obviously need a constructor, and we need to put in the constructor right there. So in this constructor, we need to initialize some data for our class. So whenever we initiate a blockchain class, we need to initialize or initiate a data with that, set some default value for this data. So the first thing that you need is to create the chain itself. The chain, what it is, it's actually a simple array. So a chain is an array, and inside that array, what we're gonna put is a bunch of blocks. So a chain is a bunch of blocks linked together. How we're gonna link that chain together is we're gonna use the hashing system. So I will show you how actually in a second. So let's first create the chain. So we're gonna use this chain, and we're gonna call this or give it like an empty array since we are just initializing things. And since like this is gonna be like a deep currency thing, and this is what actually blockchains are widely used for, so we need some transactions. So remember, once you are under like a cryptocurrency or under a currency, what you need is to send, or to be able actually to send and receive money. So this is called transactions. So transactions has some kind of data from the recipients, the sender, and the amount of data that we want to send from the sender to the recipient, so the recipient can receive this data. So this is actually what are transactions. There's a bunch of other things that you can implement in here, but this is like the basic thing what you can do with it. So here we're gonna call it transactions, and we go ahead and create that. Also gonna call it this .current. So current, just a shortcut for current transaction. Transactions equals an empty array. Simple, easy peasy. So this is all we need to do, just initialize some things, and this transactions gonna be like the current transactions. Also, we need a bunch of methods for that. The first method is add new block. So we need, or this method gonna allow us to add a brand new block into actually the chain. So this will allow us to add a brand new block to the chain. So actually for the block, what we need, or the basic structure of a block, is having an index, a timestamp, a transactions array. So like any transaction that are gonna happen in this block, and obviously the hash of this block and the previous hash of actual the previous block hash. Why we are storing the previous hash block? So this is actually how the linking works. So to link like a block with the next block, or the current block with the previous block. So linking like this will create a chain. So just giving it the previous hash to the previous block's hash, and that's it. This is how you can create a chain, and this is how you can validate or check if this chain is valid or not. So here we're going to allow us to create a new block. So let me just go ahead and create that block. It's going to be like an object. Simple. So here we need to like pass in a couple of things. The first thing what we need to pass is the actual the previous hash if we need that block. But we can grab this previous hash in a second. Actually, we need also the timestamp, the index, and transactions. So for the add new block, what it takes as an argument is the previous block's hash, so we can create the actual chain. And here the first thing, it takes the index, and the index comes from, we say this .chain.length, and we add 1. So the last element has been added to the chain plus 1, since we're gonna add a new element to the chain. So this is how we can measure the current block's index. Also, we need a timestamp. The timestamp is going to actually represent the time that the actual block has been created and added to the chain. So the timestamp gonna equal date.now. So the date, the actual or the basic JavaScript date object, and we are accessing it, and we're just gonna give it or grab the now method, which gonna give us the timestamp. Then since the Unix timestamp, you should know about that a little bit, so you can check it out. So here we've grabbed actually the time that the block has been created and added to the chain. The other thing is the transactions, so we can call this transactions, and the transactions are actually an array, so we can access this current transactions, obviously. So you need to assign the current transactions, and the last thing we need is the previous or the current hash of the actual block. So we would have like, this is going to be like the hash of the current block. So for now, I'm just gonna put it null. I will talk about this in a second. And the other thing is going to be like the previous block's hash, which gonna just be the previous hash. Simple as that. So now let's just go ahead and add to the chain. And we can use this .chain since we have already declared that, and we give it the push, and it's just gonna push and brand new block. Also, the current transactions, what it represents is like you can add a transactions. We're gonna add another method here that's gonna allow us to add new transactions into this array. And like whenever we try to add a new block, all of that transactions that we have cooked, So they all of them gonna go into this block, the particular block that we have created after adding a bunch of or only one transaction to the array. Then after adding the block into the chain, what we need is to clear that transaction so we can add new transactions that are gonna be added in the future to a new block that we're gonna assign or add to the chain. Simple, easy. So here we can go with current transactions, and here what we need is to clear these things. So we just assign it to a new empty array. Here we go. Now we have just gone through that, and just for extending that, let's just go ahead and return the block, and that's it. Now let's add the new method, which can allow us add the new transaction. So transaction actually needs three things. Needs a sender, and like all of them are strings. So the sender, the recipients. So obviously the sender, the recipients, and the actual recipients, and the amount of money that the sender sends. So here we go. Let's go ahead and just call a transaction, or just directly add that. So we can go with current transactions dot push, and we're gonna add an object into this. So we can call like the sender, the recipients, and obviously the amount. And the cool thing I like about ESX, so you don't need to put in here amount and an amount. So you specify the key and then the value that you want to put it into this key field. So just put in the key, and gonna automatically fill the key with this name. Obviously I'm just gonna go ahead and look for the same variable name in here and just grab the value and put it in here. So ESX is gonna do all of that for you. Obviously if you're using, like in our case in here, but since we are using Node.js, so this is gonna be like the same thing for us. Here we are just adding a new transactions to this. Also we need like a couple of other things like is empty. So this is empty, what it does is just gonna go ahead and check if the actual like chain is empty or no. So it returns true or false. So we return this dot chain dot length. So the length is going to represent the length of the items that the chain has. If it's just going to equal to 0, I'm going to return that going to be like equal to true, so it's actually empty. If this is going to like bigger than 0 or greater than 0, so this is going to evaluate to true. Just simple as that. This is what we need to put. And also we need another one which is going to help us to get the last added block to the chain. So just getting the last added block will help us a lot. So here we're going to return this dot chain, and this dot chain, what we need is to use the slice. So the slice method is going to allow us to get only one portion of this array, and as you can see here, we need to give it a start number and an end number. It's just going to return a new array. If like you can say from 0 to 5, it's just going to return from 0 to 5 index. The actual items are into this interval, or are actually exist into this interval. If we try to add like a negative number, it's just going to start from the end and comes all the way down to the beginning. So here we're going to just say -1, and this is going to grab us the last element has been added to the array. Obviously just going to return an array also with only one element. So accessing that, we need to grab it or to give it like the first index, which is the 0, and here we're going to just return the last added block into the chain. Simple. Now we have got all of that ready and actually good to go for us. So what we need now, this hashing is null. Now we'll just go ahead and add the hash into the actual block. So to do that, or to add the hash into the block, so after creating a null, so here we have the actual hash. So what we can do, or let me just go ahead and get rid of it, and what we can go ahead and use, we can use the actual object hash class. So let me just go ahead and include that. So this is called hash, and we can require it from npm. So it's called object-hash, and obviously make sure to go ahead and install that using npm, and make sure to initialize all of that directly as in Node.js. I've totally forgot about talking about this, but I have a full course series on my website as well, talks about Node.js and how actually everything works. So make sure to go ahead actually and check things up for that. So as I've said, go ahead and install this. Just type in npm install object-hash, and you are ready to go. Simple as this. So here we've grabbed the hash. This function or this object here going to allow us to hash things up using like standard hashing algorithms, the SHA-256. If you're familiar with that cryptography algorithms, you can Google this, and I'm just gonna give you crazy result. So we're just gonna assign this hash equals hash, or not hack, I don't know what I'm saying in here, and we're gonna hash the current block that we have created. Remember, the hash represents the current block hashes, so this is gonna help us to hash. Obviously, it's called object hash, which is gonna allow you to hash any object into strings, and this will return a string, if you can notice in here, and it takes an object, and options are like optional things. So here we're just gonna put the hash, and we are actually good to go. So we can access hash, we can put into transactions, we can add transactions, and here we have got like a constructor. The last thing we need now is to export things up using the export modular. So we can say export dot, and we need to actually use the modular. So for that, so what we want is modular dot export, and this is gonna equal to BlockChain. So we're just gonna assign the class reference, not an instance. We're not creating an instance in here. Now all the work that we need is actually under the main.js, and obviously I don't know why I've created this block.js. I don't need it anymore. So we just actually need the blockchain, and here we go. Now let's just go ahead and acquire this blockchain from the actual folder, and we need to create an instance of this class. So let's just go ahead and initiate this class, and we call it blockchain. We create an instance calling the new blockchain, and here we go. Now we've got actually an instance, and we have initialized our blockchain. So let's just start working on this blockchain. So how actually we're going to work on this blockchain is like we are going to add blocks, but blocks are not going to be simply added into the blockchain. So if you're familiar with Bitcoin or any other cryptocurrency, it's not that easy to add blocks. So this is called actually mining. So mining is adding blocks to the chain and like verifying, validating, then adding them to the chain. So making the chain bigger, and where actually the blocks only has the transactions and stuff like that. So all of blocks has some kind of a data, and the most important data inside that blocks is the transactions, which has the sender, the recipient, and the amount of money sent between the sender and the recipient. Simple as this. But wow, actually things actually work is mining, so it takes a little bit of time, where adding a block is just very simple. So they use some kind of algorithms and way to make it a little bit harder to mine a block in order to make it a little bit hard to gain money or to gain bitcoins, or if you're actually familiar with bitcoins or mining on cryptocurrencies, which we have like seen in the last couple of years. Especially in this year, 2017, 2018, that was like an insane thing happening on the industry. So yeah, just go ahead and check it out or learn more about it if you're not already. So now what we want is to create like a couple of methods that are going to allow us to add new blocks, but we need to validate things up or to create hashes in order to be able to create a block or to create a block and add them to the chain. So let's just first things first, we're going to create a proof. So this proof is going to be like the proof we're going to check actually against. So this is going to be like the real proof. Whenever we reach that proof or we generate this proof, then we are good to go, so we can add the new block. So let's just go ahead and just use a number in here. On any cryptocurrency out there has its own algorithms and a couple of other things for like checking things. So this is gonna be like the basic way is adding numbers. What usually you can find is a real long strings of randomly generated characters like a $sign and stuff like that, hashes, and they hash that thing, and it's a little bit harder, but we're gonna just take the easiest step and we're gonna try to randomly generate this number. So if you're gonna find this number, then we are good to go and we can add a new block to the chain. So now let's just go ahead and create the instance of the class or the method that's gonna allow us to validate the proof. So valid proof, and this is gonna return true or false whether the proof is like actually valid or not. So here we go, I've got this function and I'm using ES6 arrow function in here. So you can use a normal function, it's not necessary to do that. So here what we want is to create a guess hash. So, and we're gonna equal the hash, and here for the hash make sure to include or require actually the hash or the object's hash modular for doing that. So it's called object-hash, and this is going to allow us obviously to hash in the proof. So we can pass in the proof, and these are going to be like our guess hash. So we can just console log our guess hash just to making it looks a little bit peachier. So you will understand what I mean when I try to like run that in a second or in a minute after finishing this. Here we're just gonna give it like hashing and give it the guess hash, and obviously the guess hash is only a string or a hash string that has been hashed of this proof. So this is going to return a string. I'm going to store it into the guess hash. Now we need to return, since this function returns true or false, whether it is valid or no. So we're just going to return guess hash equals the hash of the real proof, and the real proof is const we have declared into the global scope and 156. Let's actually make this a little bit harder, so make it 1560. So just make a little bit harder and a little bit longer to find the hash. And here we go. Now let's just go ahead and create the function that's gonna allow us to randomly generate the number, and each time we get that proof and provide it to the valid proof, and if the valid proof is actually valid, or the proof that we have got is actually valid, so we can get out of this loop. Else we're just going to continue looping and incrementing the index until we get into the right hash, and we can just add a new block if we get into the right hash. So here, I don't know why I've talked this valid proof. What is that? Okay, now I'm just going to call it proof of work, and this proof of work going to allow us to make a loop. So I'm just going to create like the proof equals 0. So it starts from 0, and I'm going to create a while loop, while true. And this is like an infinite loop. So it will be an infinite loop if we're not going to use the break statement to get out of this loop. So make sure to do it, or this is like a bad approach to say while true if you're not going to use the break statement into that loop. So this is going to be like a very, very bad approach. Don't do that unless you are actually knowing what you're doing. And here we're going to just go ahead and check if not valid proof, and we pass in the proof. So if the proof is not valid, what we want is to increment the actual number. So remember, this is like a number, and our proof is a number. It's not a string. It's not very hard to guess about and convert between ASCII or Unicode strings into numbers and vice versa, and so on and so forth. So this is like numbers. All we need to do is just go ahead with the proof, and we say proof plus plus, and here we go. Else, if like the proof is valid, all we need to do is just call the break statement, and we can get out of this loop. So if we are out of this loop, we need to return the proof. So all we need to do now is just make both of these methods work together. So all we do in here, so we say if the proof of work, so we are actually calling the loop statements in there, and we try and actually to randomly generate a number and check against each number we generate using the valid hash like method, and we hash the number and we check against the real proof and vice versa. On like a real world example, it's not gonna be that easy, so you're gonna have like a lot of algorithms for checking and like a lot of services running, so you can just submit the proof into the server and say if that server works or no. And also you're gonna need like a lot of GPU power. So I'm saying GPU, not a CPU, because mining is like has been using GPU's power for hashing or creating like random hashes and check against the real hash in order if it actually works or not, or if it's actually valid or not. So here we say if proof of work equals, and since this is gonna return the proof, the actual proof number, not a hash, and since we have our proof in here, so we can say equals proof. If that everything is working pretty much fine, what we need now is to add a new block into the actual chain. So let's first add a new transaction. So we can do with the BlockChain and the instance. So we'll use add new transaction, and here we can add a new transaction before adding a new block. So let's say like the sender is going to be Islam, the receiver is going to be Alex or something, and the amount of money or the amount of things that onto this cryptocurrency, like on Bitcoins or something, let's say like 200 Bitcoin. That is a really ridiculous number, but you know, let's just try to do it. And using also, now let's go ahead and add a new block. So we add a new block. The only thing that we need to grab is the previous hash. So let's just go ahead and grab the previous hash. So we say previous hash equals, and to grab the previous hash, we need to access the last element on the chain. So the last block from the chain, we grab that, then we access the hash from this actual last block. So we can say blockchain dot last block. So remember, this method grabs us the last block, so we can grab this thing and we can say hash, but we need to check if this like the first block that I'm gonna add to the chain, which means there's no last block exists. So this is like the first element that I'm gonna add into the chain. Like the chain is empty right now and we're gonna add this new block. This is gonna be like the first block to be added into the actual array. So when trying to find this, it's gonna return an undefined, and we don't actually need to return an undefined. What we need to else set the previous hash. If this is like the first block, we need to set it into a null. So we need to add like a quick if statements in here, and you know, like the inline if statements, and we can say if last block dot hash, then we can grab in the last block dot hash, else if there isn't, so we're just gonna return null. So you should already be familiar with this like inline if statements. This means if this is valid, which means if this is not undefined, so do this, else if this is like undefined, else do this. So this is going to evaluate to one of these, either returning the hash from the last block or returns null. So if we are in this case, it's just going to return null, and this previous hash is going to be like null. So here all we need to do is previous hash. So if whenever we add the first element, then the second element, all of them going to have the previous hash, since everything has the last block added before it. So you've got the point actually how everything actually pretty much works. So now we have got the proof of work. The last thing we need is just to double check that everything is pretty much working fine, and then just go ahead and console things up into the console, or log everything up into the console. So here I'm gonna say the blockchain, and we can grab in our array, which is gonna be like the chain. And here we go. Now we've got that. Let's Control S and save everything up. And let me just go ahead and run this using Node. So say node main, which is our main.js, and pressing enter. And as you can see, we get a really nice hashing thing. And here we go. So we can read a property hash of undefined, which is like the last block dot hash. So as I've said, this is like an undefined, so yeah, we can't read things up. So only we need to check if this is like an undefined, we need to return the null, or else if it's not undefined, we only need to grab in the hash. Now testing again. So let's just go ahead into the own terminal. If you're not using Visual Studio Code, the code editor, make sure to go ahead and use CMD or any terminal or whatever OS you are running this. So yeah, make sure to do that. Just node main, and here we go. So as you can see, we get the hashing, or like hashing, guessing for the hash, for the right hash, or trying to actually find the right hash. And here we go. The last thing we did is find the last hash. So we added that with the index first. The timestamp is going to be like the milliseconds, or the seconds, since the timestamp of 1970, the Unix timestamp. And here we've got the transactions. It's just like a hidden objects, and the previous hash is null. So that was actually pretty much, guys, that was very basic thing. So there's like a lot of implementations of the blockchain. There's a lot of things that you can do for validation, for proof of checking or proof of work, and hashing, and all of the algorithms that can work in order to be able to add a new block to the chain. So that's actually, guys, hopefully you've enjoyed this video. So that's actually a very brief introduction, and just trying to make a very simple blockchain on Node.js as well as JavaScript, and just using the object hash like model in here that can allow us, or helps us to actually hash an actual object, which is our block into the chain. So again, that was it. I will catch you all, guys, in the next video tutorial.